start off with the homework. And Taylor's listening to this, so we have to make sure everything's done correctly. All right. Delta Y. Actually, I was thinking, quiet please. If you need something to do, work on 19, and I'll catch up with you. Delta Y is actually supposed to be f of x plus delta x minus f of x. It's the difference in y. So for number 9, delta y would equal 1 over x plus delta x minus 1 over x. Then you have to get a common denominator. This is why you did all the trig identities, was how to work on one side of the equal sign. Oops, sorry, you're just going to multiply that one by x over x. I don't really do this stuff a whole lot during the year. This is like a 1 week a year thing, x plus delta x. So my denominator is going to be x plus delta x. My numerator would be x minus delta x, which would equal negative delta x over x plus delta x. Okay? Yeah, times x. Thank you. Times x. Okay? So that is the first one, delta y. dy, well, that's not too difficult if you look at this as x to the negative 1, or you can use the reciprocal rule. But anyway, dy is going to equal negative 1x to the negative 2 dx. Or another way of looking at it would be negative 1 over x squared dx plus u. That's number 9.
What is the negative 2?
In the power rule, you subtract 1 from the exponent when you drop this down to multiply by the coefficient. And then finally, C. It says what's dy minus delta y, and that is this, negative 1 over x squared dx minus negative delta x over x plus delta x times x. Woot woot. Well, unless you have numbers, you're not really going to combine a lot of things.
So for C on all of these, we could just put that minus that.
Well, that's basically what you're doing. I mean, if you don't get fancy with some algebra, I mean, you could get a common denominator, but that's about all you're going to do. I mean, you're not, okay. C, if you want to simplify it down to the back of the book answer, that's if you're going to write a program, okay? If you're going to have a program, you want everything boiled down to next to nothing because you're always fighting memory issues when you write a program. So you want everything as simplified as possible. Here, I'm not going to put numbers in, and I really don't get anywhere by solving it, so I'm not writing a program, so I'll just leave it like that. Yeah? It does. 2 negatives make it a positive. Okay? Now, there is a point in time where, I mean, this stuff is important, but the letter C, that comes from the error part later on, but you're going to be using numbers for that, so that's not too difficult. 21, I can give it a shot. Is it hard? $21. Yeah. Hey, how you doing? All right, let x denote measurement with a maximum error of delta x. Use differentials. That means dy and dx. Okay? Differentials. We had that talk yesterday about the difference between delta, and we had that talk about differentials. To approximate the average error, which Chase Cox told us yesterday was dy over y, correct? Okay? And the percentage error, well, there's a percentage, I'm assuming you're going to multiply by 100. Sounds great. What is dy? 12x to the third times dx all over y, which is 3x to the fourth. I didn't put any numbers in there yet, but I'm going to. Now, you guys have heard of this term, plus or minus 0.01, but you haven't worked with it in that light before. It's like give or take, or close to, or approximately equal to. Is that corner about ready? Nice. All right. So this is 12 over x dx. So I just put the numbers in, don't I? 12 over 2 times plus or minus 0.01. Yeah, what did I say? Yeah, 4 over x. Thanks. I was worried about running out of space, so I think I'll just do this. 4 over x dx. This gives me some room. I can squeeze it in. 4 over 2 plus or minus 0.01, which gives me plus or minus 0.02. And do you have any idea what this means? Really? You gotta be kidding me. Yeah, well, maximum means I multiply by 100 and I get plus or minus 2%. Okay? Do you know what that means? No, 2%. All right. This plus or minus 0.01. 2 means I can have an x value of 2.01 or I can have an x value of 1.99. Okay? You see how delta x is plus or minus 0.01? So I could go up or I could go down 100. Okay? The y value, if I put it in there, is going to be 2 to the 4th of 16, which is 48, right? 48. Well, how far off could my y values be if I'm off by 100th down here? We just calculated the y's could be off by, 200ths. What do you get if you put 2.01 in the equation? Grizz, what do you get? She was out there, now she's back. 3, I know, I want you to take 3 on your calculator, 3 parentheses 2.01 caret 4.
What? Caret what?
4, as is in the problem. 967. And what's it down here? If you take 1.99 to the 4th times 3. I'd ask Graham, she's busy. 3, 1.99 caret 4. That was a sigh. 47.047. Okay? That's a 2% swing either way. You're off by 100th, you're off by 2% either way at the top. Okay? That means if you're building a house and somebody's off on the foundation by 1/4 of an inch, it throws everything off all the way to the top of the house. The air gets transferred through everything. Okay? You can't measure things exact. You have to have a range of acceptable tolerances. Okay? So if you're off by 100th in your original calculation, you could be off by 2% in your other calculations. All right? This is how all the word problems are set up. The only difference is they use words in between the numbers. You're doing the same thing over and over. You're calculating how far off if you're off here, how far off can you be over here. Have you ever seen the show called Top Shot?
Yeah.
If you're off a little bit on your sight, how far do you think that affects your target down, I don't know, 500, 600 yards? A lot. That's the differentials, okay? So that's how it works. So that's what you're going to be doing in these problems. Yes?
You can say real quick.
I can try, and then we got to move on. 15. Which one is it? It got cut off. The scan did. Okay, this one? All right. What am I supposed to do? Approximate the change or approximate the y value? Find a linear approximation. Okay, so I'm supposed to find an approximate value. All right. Well, I'm assuming that everybody did f of 27 degrees is approximately equal to the function value of 30 degrees plus the derivative value of 30 degrees times negative 3 degrees times pi over 180. Is that what you did, Stephanie? Excellent. Is that what you did? Good. So the function value of 30 degrees is going to be Sine of 30 is a half times 2 is 1 plus square root of 3 over 2 plus the derivative, quickly, will be 2 cosine theta minus sine theta. If I put in 30 degrees for that, that's going to give me square root of 3 minus a half minus pi over 60. That's approximately what 27 degrees is going to equal. Can I combine those? Yes.
So don't we need to multiply the derivative by the,
Yeah, how?
by the,
Like that? Yeah, I forgot my parentheses.
multiply the.
I took 3 times the 1, or 3 and 180 and simplified that. Well, it's a negative, not subtraction. Thanks. Oh. Can you simplify this? I don't know, maybe. I suppose you're going to tell me they went all the way down to like one single fraction in the textbook. Decimal? Pshaw.
So we can just do it.
Well, I'm trying to think. I don't know. 1 plus square root of 3 over 2 plus, sorry, minus. See, I think if you're going to a decimal, why don't you just punch in the calculator? Square root of 3 pi over 60, because it's a negative, plus pi over 120. Yeah, I'll probably leave it like that. I would. I don't know, does it come out to be close? Huh? 1.8? Well, I'm sure it comes out close.
At 160, 120 degrees.
No, there are no degrees because it's a real number. Okay? All right, Vern's about ready. Are you ready, Vern? Okay, we're ready. Time to move on. You ready, Grizz? It's going to be exciting today. Ha ha. All right. Oh yeah, this is the yeah. This is, I was talking to somebody, I got a little bit ahead of myself in the lesson. This is the change in R. So this is the dr, or also the delta R. Yeah, I just said that. Okay, this is R. Trying to find dV over V. Okay? The maximum error in the calculated volume. So now we're going to go on and, haha, I thought we did yesterday.
We did that one. We did that one already.
Yeah, didn't we do that one? No, we fixed it. We put the 12 in, divide plus or minus 0.06. We did it this way. What's the volume of a sphere? Pi r cubed. And what's dV equal to? 4 pi r squared dr divided by V divided by 4/3 pi r cubed, which equals 3 dr over r. This is just like the one we did on 21. 3 times plus or minus 0.06, all divided by 12.
We accidentally messed it up yesterday.
I put in plus or minus 0.06 without the 12. I was a day ahead of myself. Okay? So, anyway, look at this. I mean, you have to dig out everything in here. This is going to be great. It is.
I need 2 pencils.
The length L. I have no idea what to do, but we're going to have fun. And if we don't know what else to do, we'll do some IQRs, just like in stats. That's what we do for fun. Yeah. Ready? Those are the interquartile calculations.
Oh, those are fun.
Ready? It's estimated to be 32 feet with a possible error plus or minus 2 feet. That should tell you that this is equivalent to delta L or DL because it's associated with the length of the boat. Oh, wait a minute, length of the whale, sorry. You can measure the boat. That's the length of the whale. Okay? You ready? All eyes up there.
You guys are there. What are you talking about?
Okay, research has shown that the weight of a whale in metric tons is related to the length of the equation by this. So if something is a little bit longer, it's going to weigh a little bit more based on this equation. Sounds pretty good. So we have L to be 32 feet, that's of the whale. And we have delta L or DL to equal plus or minus 2 feet. So far so good. That's about all the information I've taken from that one. Now, use differentials to approximate the error in estimating the weight of the whale to the nearest tenth of a metric ton. How do you approximate the error in estimation? We'll go to our error expert in this section, Chase Cox. I do what?
Well, you do I don't know.
What? You were there. Isn't this a dW over W thing?
Yeah.
What? What's the derivative of W?
Yeah.
All right, what do you get when you multiply those? Graham's going to get a calculator here in a minute.
4.3566 times 10 to the negative 4.
All right, so 0.12, and what was your numbers?
43566.
43566. L to the 2.18, right? Times DL. All over 0.000137 L to the 3.18. You don't sound very impressed with that. Yeah. That was like a a matter of fact, like. Now, what is 0.0043566 divided by 0.00137?
Is the GL part of the top?
Yeah. 3.18.
3.18.
L to the, oh, 1 over, or over L, sorry. Divided by L times DL. Well, you subtract exponents, don't you, when you divide with the same base? I think we're ready for some numbers now. So the L was 32, and the DL is plus or minus 2. Divided by 32 times plus or minus 2. I don't like.
What's the deal? Plus or minus 2, you said?
Plus or minus, yeah. And what do you get for the calculation? 0. What? 19875. I think that's, yeah, nearest tenth, so it'll be plus or minus 0.2 metric tons. A metric ton is obviously involving kilograms, I would assume.
It's funny how they use feet and tons in the same.
It is. Wait, what's this pull tab over here?
Use that.
Is it?
Slowly.
How do you get plus or minus 1.7?
Something wasn't doing the right one. Did you do the first numbers?
No, no.
That's weird.
Plus or minus 1.7. Wait a minute. Chase? Is the word average in this?
No. Approximate.
So you don't have a, what's the error measurement? Does it say? Hey, what's 3.18 times plus or minus 2?
1.7.
Is it?
No, it's not.
Oh, I know what. I got the wrong equation from Chase.
Bad.
It's okay. There.
I don't, I'm lost.
Easy.
So we don't have a DW over W, it's just DW.
Yeah, it's just DW.
So then, oh my god. See, now we have to figure out a list, and you just pulled those tabs over.
Well, I usually don't pull the tabs. I'm surprised they were there. I don't usually make tabs. Oh, yeah, it's that easy. See?
Yeah.
Okay.
I guess if it says averaging it, you divide by the original. Yeah, it's not after the average, approximately the average error like the last one's just the error. Oh, good thing we figured that out.
Yeah, that would have been fun for the homework. Where'd you get the 3.18 from?
32. Oh yeah, you drop the exponent down. 3.18 is the exponent. Phew, that was close.
Oh,
So that's just error. That's not average error.
this is approximate to error. I wouldn't
Yeah.
have thought that was average.
So the weight could be off by plus or minus 1.7 metric tons. All right, let's try another one. Okay, I'm ready.
So why didn't you divide it by W?
Because the word average wasn't in there.
It just says error.
Right. Which would make sense because it's not the actual Y value. I'll think about more of this later. Oh, here's the one we were looking for, the average error. We already did that one. Hey, guess what the answer is going to be? Hey, woo woo!
Wait, I really don't.
I'm not. This is cool. The only thing cooler is Graham's mustache, but everything else is pretty cool.
Calm down, Henry. It'll be okay. Doesn't have to be cool. It's cool.
Sure it is. Oh, I want to drag, I want to pull this down.
Unrelated.
There, I want this. Yeah, there's the percentage error. What do you think that's going to be? 20%. Yeah, this is average error. The other one's error. Percentage errors, you multiply your average by
This
100.
one percentage. Or is it just average? Or-
No, it says and percentage.
Oh, and-
So this is the percentage error.
No, this isn't percentage yet. Percentage average error would be 20%. Yeah. We should.
We don't use our calculators much unless we get big decimals.
Yeah, exactly. We should do the next problem quickly.
Let's do it.
Ready?
Now.
Hey, it's Nick Gear Senior Night. We gotta hurry up and get going. Tomorrow. All right. All right. Now, this one we're going to try to do from start to finish and get it right.
That's a good idea.
That, as somebody just said, the word average is in it once, but it's in twice. This means that dW over W equals plus or minus 0.08. This means you're looking for dZ over Z. That's the question. I know Z equals 40 W to the 2/5. I know dW, you don't know W. Plus or minus.
Yeah, W is
No, the average error in W
Oh,
is plus or minus 0.08. You don't know what value it is, you know it's off a little bit.
would have been easier that way though.
So we go to what we're looking for. What's the derivative of Z? (16W negative 3/5) times dW. Z is equal to 40W to the 2/5. That's it. No, that's the first step. You don't know. No, dW over W is 0.08. No, dW over W is plus or minus 0.08. No. No, but what's the negative exponent going to do? And then what can you do? Add. What is 3/5 plus 2/5? So 16 over 40, dividing both by 8. You have 2/5 W with a dW right here. Nope. Now in place of this whole fraction right here, you can put in plus or minus 0.08 times 2/5. You don't have an actual value for W or Z. You just have an average error for W. I don't know. I got to do the pull tab. I just saw that. I'm like, uh-oh. Got a pull tab.
Let's see if we got it right.
Let's see if we got it right. What is 32? Yep. Oh, pull tab. Woohoo! That was a long one. That was a Denny Crane right there. All right. All right. Ready for the next one? Yeah. That worked today. What's that mean? 5? Okay. Okay. An isosceles triangle is equal sides of length 12. If the angle between them increases from 30 to 33, use differentials
Oh my god.
to approximate the change in the area. Does this have the word average in it?
No.
So I just have to find dA. dA is the change in area. Nope. Nope, this one gives me an initial value of theta. That means d theta is going to equal 3. Equal sides of length 12. Yeah. That's where you're going to. You're going to 33. Yep, 30 is theta. And 12 inches is the length of the sides of the isosceles triangle. So how do you find the area of a non-right triangle? 1/2 BC sine of A theta. So that'll be 1/2 12 times 12 times sine of theta. The 12s aren't changing what the theta is. So the area equals, what's 6 times 12? 72? 72 sine of theta. Right. Isosceles. So I need to find dA. That's going to be 72 cosine theta times d theta. Oh, that's pretty easy. 72 cosine of 30 times 3 degrees times pi over 180. Root 3 over 2 times pi over 60. Oh, pull tab. You know what that means. It does. Let's see if there's anything resembling what we're doing. Oh! Man, it's like a Denny Crane. Woo-woo! I think we're good, don't you, Lou? We have this part right here, don't we? Nice. Now that one we're going to stop, and that is question number 80, I believe. So you can go through all the 70s.
It has an 8 in it.
Oh.
That's a good question.
How many? So get to 35 odd. You can do every other odd if you like.
That's something.
Wait, where do we?
23 to 35 every other odd.
So the ones up.
And back by popular belief, or Alex want to make sure remind you to do number 19.
19.
Did you want to do 19, Alex, or not? Oh, he didn't want to do 19. Never mind. We'll save that for later. Thank you, Taylor, for listening, and have a nice day.